FIRST is an organization created to inspire students in engineering and technology fields. As of 2009, over 3,000 high school teams totaling over 46,000 students from across the world compete in annual competition. First of all, let me introduce us. We are robotics team number 116, Epsilon Delta, which means from small changes come big differences. Our headquarters are in Herndon, Virginia, in Herndon High School. As part of the FIRST organization, we provide high school students, and sometimes even younger kids, with an experience of what the real engineering world is really like. We have actual engineers who work alongside students to build a robot, program control software, build mobility systems, and much more. Our team has inspired many people from our high school to pursue careers in engineering, including a muscle car test driver. Our recruitment process at the beginning of the year starts off with the most exciting 2-hour competition you will ever experience, Uncle Milo. This squeezes down the multi-month build season into the span of about 2 hours. Now, at the start, everyone gets a bag filled with a bunch of random things, such as popsicle sticks, 2 balloons, some chopsticks, and a few other random things. The object of the game is to suspend a heavy metal weight as far sideways and as high as possible away from the metal bar. Your structure may only touch the metal bar and the table on the side of the tape opposite the metal bar. So this one's a tower that balances directly on top of the metal bar. And this one uses a triangular support beam for stability. This one is actually like a teeter-totter. It uses spare supplies as a counterweight to balance the heavy metal object on the other side over the bar. Now, the Uncle Milo game only served to give the students a taste of what was to come. A worldwide competition between teams to build the best robot under 120 pounds. Last year's game involved 2 teams of 3 robots, with each alliance attempting to place as many inner tubes onto their pegs as possible. We designed a robot with a rotational gripper attached to a telescopic lift, aka the elevator. We almost won our competition in New Orleans, but lost in the semifinals. Now, after Uncle Milo, the training season begins. The team is split into its various subgroups, and each of these groups work on their own group projects. So there are 3 main subsections of our team. The first subsection, the FRC team, builds the main robot. Most of our members are part of this team. The second subsection is the FTC, also known as VEX team. This group works separately from the rest of the team on building smaller robots and goes to separate competitions. The final subsection is the animation team, which makes a 3D animated video similar to Pixar or DreamWorks. First, let's talk about the FRC team. The FRC team is divided into several subgroups: frame, mobility, manipulator, inventor, programming, and hardware. Now, of these subgroups, the frame and bumper group welds, cuts, and solders together the aluminum frame, as well as fits the bumper onto the bot. During the training season, this group's project was to build a square aluminum frame. The next subgroup, manipulator, is usually very large. It builds devices to manipulate its surroundings, such as hooks, claws, rollers, and wedges. The manipulator subgroup project during the training season was to build a giant Nerf gun, the pacifier. Featuring an epic loading system, the pacifier used a long length of PVC pipe with a plunger powered by elastic tubing, which pushed the dart through the pipe very quickly.
The Nerf pacifier dominated the competition. By no one.
The next subgroup, the inventor team, built a 3D schematic of the robot using architectural software. This is important because it is used to integrate the various subsystems together. For example, if Manipulator decided to design a gripper to occupy the same space as where the mobility team planned to put a wheel, the inventor team, after receiving these conflicting plans, would tell one of them to change their plans. The next subgroup, the programming team, writes code for the robot. This code gives instructions to run the wheels, activate pistons, and monitors sensor input from devices such as cameras and line sensors. This group's project during the training season consisted of, teaching all of the 2B programmers how to program. The final subgroup of the FRC team, hardware, deals with the interface used to control the robot. This usually includes several dials, switches, buttons, and a few joysticks. Or, since we're awesome, we use PS3 controllers. This group's subproject during the training season was to build a box with an on-off switch. When the switch is flipped on, a flap on the top of the box opens, an arm comes out, and the arm turns the switch off and retreats back into the box. So basically, when you turn it on, it turns itself back off, which is awesome. We've talked about FRC, so now let's talk about FTC. The FTC, also known as VEX team, works separately from the rest of the team, working on smaller robots and going to separate competitions. We have a notoriously good FTC team, and we actually won the FTC World Championship in Atlanta just a few years ago. And finally, last but not least, is the animation team. The animation team works on a 3D animation using software called 3ds Max. Every year, FIRST has a different prompt about what the animation has to be about. Not including this year, our team has won first place for its animation 10 years in a row. Here is this year's animation.
An examination into the effectiveness of artificial floating communities as a means of alternative living in the event of rising ocean levels leading to global-scale flooding and shrinking land masses on an alien world.
The Eco's home planet is slowly flooding as their ice caps melt. As the habitable land area disappears, we propose the design and construction of large artificial floating communities to sustain their race. Each artificial island is self-sustaining, using regenerative agriculture for food and clean wind and solar energy for electrical needs. The islands are also designed to connect to one another to form larger floating collectives to promote communication and trade. Okay, so this is Amy Frankhauser currently being held custody by a certain Dave Lavery. This man clearly does not respect child labor laws. I really need some help here, so please save me.
Hey, back to work!